Okay, on the warm-up, it talks about which tablet was chosen by the majority, and we had a discussion in class of what they thought majority meant. They said that they thought majority meant most of the people, but that's actually not true. Like, based on your belief, you would think tablet A is by the majority of the people because more people chose A than anything else, correct? Yes. Okay, then I had them look up a mathematical definition on a device for majority. Who's got it? Let's read it. Go ahead.
A majority of components like majority is the
it's more than half of the total survey. That is what's important. So on your paper somewhere, I would write majority is more than half of the total. So in this particular question, how many people were surveyed? I think it said it at the top. Okay, so the total in this case was 250. So what would be half of 250? 125. So were any tablets more than 125? No, because the most popular tablet was this one, which is 102. So which tablet was chosen by the majority? What would you say? None of them. That's exactly right. And so I wrote underneath here, majority means more than half of the data. The total data collected was 250. Half would be 125. Therefore, none of the tablets made up the majority. Okay? If you will recall, so in a nutshell, majority does not just mean the most, it means what? More than half. And that's the technical mathematical definition. Okay? All right. Okay. All right, guys. What we're going to do now is I'm going to have you guys come up, and one person at a time, you're going to pick up a number, and you're going to sort it in one of the categories over here where you think it goes, okay? This should be a review from last year of natural, whole, integer, and rational. You understand? You're just going to put it. So don't pick one up. Like if someone puts one there and you believe it's wrong or right, whatever, don't mess with it. Like pick one up from over here, okay? And if you're at home, pause the video. Record. Okay, we just watched a quick little video, but all it did was review natural, whole, integers, and rational. What it didn't do was go any further than that, which we're about to. So first, let's talk about natural. Natural numbers are what? Regular counting numbers like we learned when you were in pre-K or kindergarten. 1, 2, 3, 4, 5. Okay? So in here, 22 over 11, that was really tripping some of y'all up, but that's what? Because it's equal to 2. 2 is a natural number. Absolute value of -6 would be what? 6. 14 is good. 3, what's 3 squared? 9 and 7. Is everything in natural realm okay?
Yeah.
Yes. Whole number. The only thing that can ever sit in the whole numbers all by itself is what? 0. And you remember that from that O and whole on O, okay? Integers are always positive and negative whole numbers, right? So like some of y'all have this one here, but what's wrong with it? It's a fraction, so it has to move out here. Now, let's talk about rationals, and here's where we got to get a little bit more detail, okay? Because the previous video was meant really for 7th grade, and we're now moving to 8th grade, okay? The difference is we don't tell you about its special rational numbers. It can be written as a ratio. Decimals are in here as long as they what? They stop, so that's a terminating decimal. So like this one, 15 over 4 would be what? 3.75, and that one works. Or they what? Or they repeat. So like this one, 157, 157, dot, dot, dot. What does that mean? It's going to keep being 157, 157, so it's repeating. Okay? So 3.14 is terminating. No, -6.8 is terminating. What about this guy?
Negative. It's a -6.
It's an integer because it's equivalent to -6. -3.2 with a repeater, is that okay? 2.56, is that okay? Negative, and then 1.2 squared, well, this is going to be 1.2 times 1.2, which is still a decimal, and then it's going to be the negative of that, so it's still a decimal, okay? Now, there's some that are hanging out over here. Why? If this is not repeating. It goes on forever, and it never repeats. Kind of like our friend we met last year, this guy. Right? This guy. What is his name? Pi. And we talked about him at the end of the year when we did circles in 6th grade. Pi, I said, it's none of these things, right? Do you remember? Happen to remember what this was? Irrational. And I said, we didn't really need to know that last year, which you didn't. But you need to know it this year for 8. Irrational. See, I had some things that needed to be changed, and then I had those guys. So you guys got it. So, irrational numbers, what? Don't repeat, and they go on forever. Okay? So that's the new thing. So guys, if you look, see how I have this poster? It's just like your piece of paper. Look at this year's poster compared to academics poster. What's the only thing that's different? There's no irrational. Okay? So what I'd like for you to do on your paper, first we need to label and describe. So first let's label before we put the numbers in. Okay? So we're going to label. We're going to say natural. What would be a good description for natural?
All whole numbers.
Whole numbers?
All whole numbers are 0.
Yeah, so I would say counting numbers. Okay? More than 0. 1, 2, ... Okay? And then go ahead and fill in those examples that we did, the ones that we did. Go ahead and fill those in. Because the reason why we're doing that is so you can see all the different ways that you might see a natural number. Like some of them look like 3, look like 7 or whatever, and then others look like absolute value, right? Okay, what's the next category? Whole. So these are counting numbers, but what? Beginning with 0, okay? And so the only thing you can put in that category on our diagram is 0, okay? What's the next one called? Integers. And what would you say for the description there? Positive and negative what? So positive and negative whole numbers, and so there you've got -18/3, -3. And then what's taken out here? Rational. And what can we say here?
No?
Real numbers?
Irrational.
Stop. How can something be irrational and rational at the same time?
No.
It's numbers that can be written as a ratio. Okay? Numbers that can be written as a ratio. Okay? And I ran out of space, and maybe you still have space. Decimals, specific kinds of decimals. Which kind? Decimals that
Don't repeat.
So what's that called if they don't repeat? Terminating, that means they stop. Or repeat. Okay? And then over here, this realm, oh, I'm sorry, I'll give you time to catch up. So you got lots of numbers over here that you're jumping over. So now we have the final spot. These are irrational. And we would say these are non-terminating, non-repeating. Okay? And they're all, obviously they're going to be fractional. Non-terminating, non-repeating is irrational. Okay? Now, notice that all of these things are inside of one big box. That big box has its own label. What is it? Real numbers. Everything in this box that we've talked about is called a real number. Now, if I'm you, I've got a question burned in my brain. Well, everything in here is a real number, so does that mean that there are fake numbers?
Yes, well, kind of.
Kind of. They're not called fake numbers. Do we know what they're called? No? Imaginary numbers. You will get to imaginary numbers in high school.
What?
It is a thing. They are imaginary numbers. I promise you'll give you a pink. You don't. They are indicated by that. That indicates an imaginary. So if you ever see it first as a little eye, that means imaginary. But you don't know that yet. Okay? All right. Is everybody good so far?
Yes, ma'am.
Okay. So again, when you, I want to review one more thing that we didn't talk about, that the video did. So once something lands, wherever it is, remember that it's everything from there out, meaning the number 0 is a whole, an integer, and a rational, right? The number 3 would be natural, whole, integer, and rational. Do everybody remember how to read that? But if I circled negative pi, what? It's only irrational, and then of course real, right? But you cannot have something be on the left side and the right side at the same time. It's like saying you're a 7th grader and an 8th grader at the same time. You can't. You're in one group, okay? You might have courses that are in another, but you are in a specific grade. All right? Guys, don't have a question. Maybe I can answer. Okay, this will take some practice, we know. Okay, what we're going to do now, switching gears a little bit, we have an activity that I want you to do. It's called a Desmos. All right, I'm going to give you a code. I'm going to finish giving directions and then so I can stop my video. First of all, we're going to start it now. If you need to finish it for homework, you can. In the Desmos, it's going to say stop. Do not stop. Please stop me. Keep going, okay? Because this was meant to be over 2 days, so we're switching into 1. So continue. Also, I'm going to pass out your test review that's due on Wednesday. Reminder, Imagine Math Benchmark due on Thursday. Canvas quiz due on Friday. So lots of reminders, okay?